let's just back up. Pretend it's 10,000 years ago. You spot a lion. That your brain goes, Dawn, save my life, run away or fight this lion. It's that classic fight or flight. So your pupils then get big to let in as much light as possible. And then the heart rate and blood pressure surge to like increase your blood flow to your brain and to your muscles. Your breathing gets faster, and all the other sensory filters are turned down. So that dimmer, we turn down the sensors because you want to hear that snapping twig, because that could be the lion's big brother. And if you go, oh, it's just a snapping twig, I'll ignore it. Well, that brother of the lion's going to eat you. So evolutionarily, for tens of thousands of years, our bodies are wired to turn off the filters, get ready to run or fight. And that high alert is why people get the headache, because their blood vessels are more sensitized. They're sensitive to the light. They're they got photophobia, afraid of the light, because their pupils are so big. They're got phonophobia, sensitivity to noise, because the filters for the sounds are off and the brain's not trying to make a decision, this is an okay sound and that's not an okay sound. It just lets it all in. And that's why they don't fall asleep well, because they are revved up and they're more worried and more anxious because they're living in that DEFCON 5 alarm state. And so that's a really interesting approach to think about. Are there ways in which we can determine if someone's symptoms are due to this as a biomarker? And so that simple lying down, standing up, it's called orthostatic vitals. We do it that regular way, but we also do it with really fancy equipment with, measuring their beat to beat heart rate variability using heart rate monitors and special software. We have a thing called a tilt table where their muscles don't engage, which is really important because the minute your muscles engage, it can affect heart rate and blood pressure as well. So this way the table moves, not you, and it does it pretty darn quickly. So it's almost like a carnival ride, but it does give us that really accurate information. And then we're also looking at how quickly the pupils use using like a $10,000 pupilometer, and it flashes a light and it measures like within, we're talking nanoseconds or nanoseconds and milliseconds, that how quickly it takes for the pupils to shrink and then get big again. And then that eye tracking. So there's lots of things that we're exploring and more to learn, but I'm honestly most excited about the physiology because anyone can do it. You don't need a specialized equipment. You don't need some of these things. And maybe we're studying it in the pupil things, but maybe we can come up with the good enough bedside / field side, rink side solutions to do these things. And maybe even as simple as lie down and stand up and see how they do.
Amazing. Yeah, no, that's great. Thank you for sharing that extra a little bit. Kind of bleeds into my next question for you. So we, as the Athletic Therapy Ontario Concussion Working Group, has been tapping into some of the concussion saliva tests, but is also very interested in the ocular conditions related to concussion assessment and care. So can you share any insights on Transcendent's unique access to the FDA and Health Canada approved EyeBOX?
Yeah, so this is really exciting to be part of. So eye tracking really gives us a window into how the brain's working to coordinate gaze. And those are symptoms that can really be disrupted commonly following concussion. So we're looking at two things with vision. We're looking at eye tracking, and that's what that EyeBOX is. And we're also looking at that pupillometry, which I talked about. So just again, very pupillometry, it's the velocity and the percentage of which the eyes constrict. It's fast, it's portable, it's handheld, it runs off a battery, it doesn't need to be plugged in. Those are things that could be a novel way to really, again, if made smarter, faster, cheaper, things that can really be expanded in the future as a field side assessment. Now, the Oculogica EyeBOX, it's a really exciting partnership we're doing. As I told you, we're really fortunate to have this grant with the Ontario Brain Institute to do this research, and there's lots of pillars. There's the discovery, there's treatments, there's knowledge sharing. Like the things actually we're doing right now is knowledge sharing to your audience. But then there's also this fourth pillar, which is kind of novel, and it's a very exciting way to think about the future of research, is making sure whatever we do makes it to care, not just a publication. And so some of that is either validating or helping new commercial partners or industry partners expand their opportunities to get things to the patients who need their products. And so we work with Oculogica, and Oculogica is a company that developed this thing called an EyeBOX. And basically, there's a choice. You sit in front of this station. It's kind of like, imagine a small computer laptop, but without the keyboard. And there's a little, what looks like a webcam camera lit up on top, but rather than doing actual photos, it's really doing infrared photos, and it's taking a lot per second. And that infrared then allows it to understand the differences between your pupil and your iris, and track almost like what would be done in like a plane tracking or some of these other tracking, it's radar lock type of things on your eyes. And it's able to put a little square around your pupil, and it just sees how they move. And then the participant sits in front of that, they keep their head still, and then they pick what video they want. And most of them are like small little short Disney or Pixar type movies or cartoons, fun things. And it moves across the screen. And so a person will watch with their eyes together how it moves. And that is that video basically collects about 100,000 data points of the eye position and pupil size. And then inside in that device, it does a whole bunch of fancy algorithms, and it comes up with a box score. And that's available within seconds after completing this, couple minute test. And it is now not just FDA approved, but it's now Health Canada approved. And so we help that company to bring it to Canada. And it's an aid. It's not, yes, you do this, you have concussion, you don't, or yes, you have this and you're cured or not. But those are things that we're exploring, is how does this tool help in the assessment?
That's
And so
fantastic.
it's exciting. It's now, as an athletic therapist, this isn't necessarily something you pick up. It's kind of like, that's why we have laptops, not desktops. And so it's like, how do you and how do people do when they're moving their head in space? Is another part, because it's looking at the eye movements. But if someone's got most of their symptoms when they've got movements of vestibular, and that's when their eyes do it, it's a bit of a different assessment. So it's a compliment, and it's an exciting thing. And I think we're learning a lot already from that, because the raw data, and maybe it's just the help, that needle in the haystack, and then we pull on that thread a bit more, and then move that really fancy thing to something that's available to someone at the field.